Hi guys, it's Mrs. Warner. Hope you guys are doing well. I'm so excited. Today we're going to do lesson 4.3, multiplying special cases or patterns. It's going to be exciting, folks. Hang on to your seats. Okay, so let's look at our first case. It says we're going to look at special products. It says, what does x plus 8 squared really mean? It means multiply it by itself. In other words, if we were to look at this, it would mean, hang on, I gotta get my pen working here. It would mean really x plus 8 times a whole nother group of x plus 8. Now, some of you guys might think that since that little squared is out there, this problem would turn into x squared plus 64. But guess what, folks? You're wrong, because it actually doesn't turn out to that. Let's look at the first one, the first example in row 1. It's x plus 4 squared. So that's like x plus 4 times another group of x plus 4. And since you guys are fantastic students, you remember from Thursday's lesson that we could double distribute or use our box method to get our answer here. And this turns into x squared plus 4x, x squared, plus 4x plus 4x plus 16. In other words, this whole problem just turned into, I'm going to write over here for a second, x squared plus 8x plus 16, because you combine those two terms in the middle. So see, if you had assumed that you just take that little square and multiply it to each of the terms, you would be incorrect, because you would be missing that middle term of the 8x. That was fun. Let's try this d minus 3 squared in row 2. That's really like d minus 3 times another d minus 3. If I multiply those out, I get d squared minus 3d minus another 3d and plus 9. D squared minus 3d minus another 3d plus 9. Or d squared minus 6d plus 9. Super fun. So you can see there's always that middle term there. We're going to take a pause for a second, and you guys are going to answer questions B, C, E, and F on the play pause it. Take your time. Do a good job. You can do it. Okay, folks, welcome back. What do you notice about all your signs in row 1? All of the signs and the problems in row 1 and their answers are all positive. So to start out with, it's like x plus 4 squared, y plus 5 squared, and p plus 3. And when you multiply out those binomials, you end up with answers that have all positive signs in them. But if you look at row 2, it starts out with minus signs. All of the problems start with a minus sign, and your answers end up to be a minus and then a plus. So there are special patterns that occur. So based on the patterns you found, my papers are floating away. Predict the answers to the following problems by doing them. If you can do them without doing your double distributing or FOIL or box method, and try to use the pattern we just found. If not, you can always resort back to double distributing or using the box method, or if you liked using FOIL from the other day, you could use that too. So these questions right here, 1 through 4, you're going to also do right now in your play pause it. When you do these questions, the answers to these patterns that we're looking at are called perfect square trinomials. They're called perfect square trinomials because at the end of each of the problems, the number is a perfect square. It's like squaring at the end. Super fun. I love my perfect squares, like 1, 4, 9, 16, 25, and so on. Perfect square trinomials. So it gets a little bit trickier though. Now there's going to be a coefficient in front of our x term. So let's look at this first example here. It says find 2x plus 7 squared. All right, I'm going to do the same process. I'm going to write 2x plus 7 times 2x plus 7. So you're going to write 2x plus 7 next to itself. And now I'm just going to double distribute. Or if you like using the box method, you could use that too. So when I double distribute, 2x times 2x is 4x squared. Now notice that that perfect square also popped into the front of the problem. 2x times 7 is 14x. 7 times 2x is 14x. So again, there's that double. And 7 times 7 is 49. Again, our other perfect square. Our last step is always to combine our like terms. So if I combine up those two like terms in the middle, I have 4x squared plus 28x plus 49. And the middle term actually comes from a pattern. So we're going to do the same idea. You guys are going to do this A and the B and try to find the pattern that is occurring there. So there's actually a rule that happens with these perfect square binomials, we call them. If you notice, the first part ends up taking the first number in the binomial and squaring it. And then in the back, it ends up having the last number squared. What happens in the middle is you take and add 2 times whatever the first term is and times whatever the last term is, and it ends up in b squared. It's super fun. So like, say it was x plus 3. I could take the x and square it, x squared, multiply 2 times the a, which is x, times the 3, which is b. So 2 times a times x, or 2 times x times 3. And if I multiply those together, I would get 6x. And then if I take my b, which is this 3 in the back, and square it, I get 9. And sure enough, if I had taken that binomial x plus 3 squared and rewrote it twice and done the double distribute method, I would end up with that x squared plus 6x plus 9. Same idea happens with the minus, except our signs change. It's a squared, and we notice that this is a minus. It would be minus 2ab, and the back is always a plus b squared. So it's kind of fun that there's actually a pattern that happens with those perfect squared binomials. The square of the binomial is the square of the first term plus twice the first, or the first front and the back term, their product is what shows up next. That's product plus the square of the last term. So you take your last term and you square that. Super fun looking at patterns with binomials. So for the last few questions, you're going to enter those in your PlayPosit. I hope you guys did a great job and enjoyed this fabulous video I made for you. It's getting cold out here. All right, guys, I'll see you soon. Bye.